Alright, on all this time off that you have, you're starting to play a game, and in this game, you roll a 20-sided die whenever you swing your sword, and on a roll of 16 or higher, then the game says you score a hit. So in one particular round, or one particular, I don't know, fight, we'll say, the die is rolled 5 times. Find the probability that exactly 2 hits are achieved. So the first thing I note is that I'm rolling the die 5 times, and it's going to be the exact same circumstances each of those 5 times. It's still a 16 or greater every single time I roll that die that achieves a hit. So I'm going to define a success here as a hit. In other words, getting a 16 or greater. I kind of jumped past the fact that I'm doing a binomial distribution here, but that's as soon as I made the observation that I'm doing 5 identical trials and I'm just determining if I get a hit or not, that's when I realized that this should be a binomial. And so I define my success, 16 or greater. So let's see, n, the number of trials, the number of times we're rolling the die, is 5. The probability of a success, be careful with one of these because oftentimes people will see this and they'll say, okay, there's 4 different ways this happens. Well, let's actually count this out. 16, 17, 18, 19, or 20. There's actually 5 different outcomes or 5 different results on the die that will result in a hit here. So that means there's a 5 out of 20. That's the probability of a success. I'm going to go ahead and reduce that down to 1 out of 4 just because it's easier to work with. And then x, we're trying to figure out the number of successes. So find the probability that exactly 2 hits are achieved. So we want x equals 2. So now we have our n, we have our p, we have our x. We can pull up our calculator and say binomial PDF. Go to distributions. I'm going to scroll up to get to binomial PDF. Enter in 5, comma, 0.25. That's 1/4, comma, 2. And we get a probability of 0.264, we'll call it. Now, because this is just going directly from n, p, and x to a probability, you'll notice there isn't really much work that I'm able to show here. So what I'd like to see generally when people are doing tests is I like to, I mean, obviously if you start defining things like a success and you have the variables n, p, and x defined, then I'm going to assume that you're talking about a binomial probability. So alternatively, you might do something like this. You might say binomial PDF, and then 5, 1/4, 2. If you write something like that on your notes, I can know exactly what you're putting into the calculator. As I said before, there's a difference between a PDF and a CDF. So right now we're using a PDF. Once we get into the CDF stuff, I'll describe the difference there.